Today we're going to be talking about topic 2.6, which is inverse functions, and I apologize for the children in the background. They are getting their baths. So we are going to, as always, make sure that we have written our last name and our first name on the top of our page. And our essential question is, how do you find the inverse of a function? And the three things that we're going to do when we find the inverses of a function is I can find the inverse of a function, I can verify that two functions are inverses of each other, and I can evaluate a function composition with an inverse given a graph. And you'll notice when I did the homework assignments for this that I've split those three distinct things kind of into three separate homework assignments. They're all fairly short homework assignments. So they seem like a lot, but it really is kind of a short. So for a function defined by a set of ordered pairs to form the inverse function of f, and we have a special notation for that. We write it as f to the -1, but we read that as f inverse. And it's f inverse, typically it's f inverse of x. And what we're going to do is we are going to switch the x and the y coordinate. So our first example here is just let the function, I lost the notebook. Is we're going to let the function be defined by these sets of ordered pairs. We're supposed to find f inverse. So I'm going to write our fancy notation. And then all we're going to do is we're going to switch the x's and the y coordinates. So I'm going to switch this one. I'm going to reverse the order. So 5, 1. And then the next one would be 6, 2. And the next one would be 3, 7. And then the last one would be 8, 4. Then to find the inverse of a function, informally think about what is happening in the function and how you would undo it algebraically. So we're going to go ahead and find the inverses. And basically, the name of the game here is we're going to switch the x and the y. When we're looking at this, you want to think of f of x as the y. So I'm literally just going to switch it to make it into y. Now I'm going to switch the location of x and y. So we've got x equals 4y. Once you get to here, we are now going to try to solve for y. Okay, so I'm going to get y by itself by dividing by 4. So we've got x over 4 equals y. Now, that's if I start in function notation, I have to end in function notation, but it's not back to f of x because what we actually did was the inverse. And I'm also just going to swap the sides of the equal sign. So I'm going to say f inverse of x equals x over 4. All right, we're going to do the same thing in example 3. I'm going to turn my f of x into y. Then I'm going to switch the x and the y because that's what it means to be an inverse. And then I am going to add 6 to both sides. So we get x plus 6 equals y. And then if it starts in function notation, we end in function notation. So it should be f inverse of x equals x plus 6. And then just a little bit about the domain and the range. So for a function f and its inverse f inverse, the domain of f is equal to the range of f inverse. And the range of f is equal to the domain of f inverse. Just another way to say, hey, x and y are switching places. To verify that two functions are inverses of one another, check that the function compositions, which is what we learned yesterday, f of g of x equals x, and g of f of x also equals x. What's really going on here is if I had a parabola and I graphed its inverse would look like this. And do you see that there's a line of symmetry right here? Well, that line of symmetry is the line y equals x. So basically, a function and its inverse are symmetric across the line y equals x, which is why when you compose them together, you will get an x.